in continuation with the previous video, we'll try to solve these sums. Now question number 16. Find the position vector of the midpoint of the vector joining. So this is an important term. This is a midpoint sum. Vector joining the points P and Q. So they have given us the position vector OP and OQ. And we have to find the position vector of a point which will act as a midpoint to the vector joining these 2 points. So we have P here. This is the point P. And this is point Q. So there is a line that is connecting PQ. So we have to find the vector in such a way that act as a midpoint. So this is my R. So the position vectors are given. So this is O. So I have OQ as here, which is equal to B vector, and OP vector, which is my A vector. I have to find my OR vector, which is my R vector. So since it is going to be the midpoint, it will be an internally dividing point. It cannot be an external point, which cannot be a midpoint. And this will be 1:1 ratio. So it will be in the ratio of 1:1. So we know the formula for R vector when the point is in between P and Q is MB vector plus NA vector plus M plus N. Here M equal to 1 and N equal to 1. So substituting that, we have R vector is equal to 1 into B vector. So generally we will take this as M and N, but since it is a midpoint formula, we don't have to worry about whether we are going to take B here or there. But still, if it is M, this is my B vector. So my OQ vector and OP vector. So the given vectors are OP and OQ. So I have 4, 1 and minus 2. So that will be 4i plus 1j minus 2k plus n into, that is again 1 into my BA vector, which is 2, 3 and 4. So 2i plus 3j plus 4k by 1 plus 1, which is 2. So simplifying this, I'll have my R vector is equal to, when I add the like terms, it will be 4 plus 2, this is 6i plus 1 plus 3, 4j plus minus 2 plus 4. So that will be 2k, the whole divided by 2, which is equal to 3i plus 2j plus k. So this is the answer. So this is my position vector of a point which divides the point PQ. So a line which is drawn between PQ in the ratio 1:1. So this is my midpoint. So the next sum, show that points ABC of position vector A vector, B vector and C vector. So they are given as the position vector ABC respectively forms the vertices of a right angle triangle. So a right angle triangle. So we all know what is a right angle triangle. So we'll have one of the angle as 90 degree. The same sum can be solved differently, but the introduction for that concept is not there, right? Right, so once we introduce that concept, you could also prove that with that method. Now here, we will try to prove it with the basic law that we have been using for right angle triangle, which is your Pythagoras theorem. So when one of the angle is 90 degree, if this is A, B and my hypotenuse is C, A square plus B square is equal to C square. This is the very basic law we have been using for a very long time for a right angle triangle. So I have the vertices. So this is my vertices. So these three are the vertices of the triangle, which is given as 3i minus 4j minus points that is given. So this is my vector B, this is my vector A and this is my vector C. That is OC vector, OB vector and OA vector. So they are given like this. Now I have to find my side. So this is my side A, this is my side B and this is my side C. So to prove this, I need the magnitude of the three sides. So let me find AB vector, BC vector and AC vector. So by knowing these three, I can compare the magnitude. So to find AB, we already know OB vector minus OA vector is AB vector. OC vector minus OB vector is equal to BC vector. And OC vector minus OA vector is equal to AB vector. So by simplifying this, we'll have AB vector is equal to, so these are the three sides of the triangle AB, BC and AC. Now I need the magnitude. So magnitude of AB is root of 1 minus 1 the whole square plus 3 the whole square plus 5 square, which is root of 1 plus 9 plus 25, which is root 35. Modulus of BC, that is my magnitude of the side BC, is root of 1 plus 4 plus 36, which is root of 41. And my modulus of AC, that is my magnitude of AC vector, is root of 4 plus 1 plus 1, which will be root 6. So now I have to check whether the square and adding any two sides is ending up with the third side square, so that I can confirm that this is a right angle triangle. For example, my root 35 the whole square plus root 6 the whole square will be 35 plus 6, which is 41, which is actually square of BC. Therefore, my modulus AB square, that is my submagnitude of AB square plus AC square, is equal to modulus of BC square. So BC is my hypotenuse, which is opposite. So I have drawn AC. This is a rough diagram. We didn't know that whether it is a right angle triangle or not. So this is supposed to be B and this is supposed to be A. So BC is the hypotenuse of the given triangle, and we have proved that it is a right angle triangle.